Again, I'm so excited to have you back on the AK Academics channel. I remain your number one instructor, Prof. Akinola. Today we're going to continue our teachings on force and motion, and then we're going to quickly look at this example together. Alex pulls with a force FA, which is 220 newtons, and Charles with a force FC, which is 170 newtons. With what force FB does Betty pull? And then secondly, what is fire? The tire remains stationary. So we're going to use this diagram or this figure to solve this problem. We have been given FA, which is the force that Alex uses to pull the tire. The tire is represented on the XY plane. You can see the tire here with this dot and labeled as tire on the XY plane at the origin. FA represents the force with which Charles is pulling, and he is pulling at an angle of 47 degrees with the horizontal. Alex's pull makes an angle of 47 degrees with the horizontal of the surface where the tire is resting. Also, we have FC, which is Charles. It pulls with an angle of phi, which is the angle that we are actually looking for, okay? And that is the angle that Charles' pull makes with the horizontal on which the tire is resting. By the way, we know FA is 220 newtons, we know FC is 170 newtons. So we do not know FB, and we have been asked to find FB. From what you can see here, FB is representing the weight, is directly representing the weight of the tire because it's lying on the vertical y-axis downward. Alright, the first thing you want to note is that the acceleration of the tire will be zero because the question tells us that the tire remains constant, the tire remains stationary. If you try to imagine this question, if the tire is stationary, it simply means there is a kind of balance. The force with which FA is pulling and the force with which FC is pulling, in addition with the force with which FB is pulling, creates a balance for the tire. So the tire is not moving, it's stationary. And when we have that kind of a situation, we say our acceleration is zero because the tire is not moving. Alright, if we take it further, you might want to find, according to Newton's law, the summation of all the forces that is acting on the tire. Newton's law tells us that the net force acting on a body or a particle is equal to zero. That means FA, which is a vector quantity by the way, because force is a vector quantity. So it means FA plus FB plus FC would be equal to zero. Summation of all those forces will be equal to zero. So now we're going to start to analyze the forces to know which one is positive, which one is negative, and then try to find the horizontal components and the vertical components of the forces. That is the easiest way or the best way to find the solution to this problem. Okay, let's take it further. The first thing we want to do here is to find the horizontal components of all the forces that we have at play. Alright, starting with FC. What is the horizontal component of FC? The horizontal component of FC will be equal to FC cos phi. FC cos the angle FC makes with the horizontal. That is how to find the horizontal component of a force that makes an angle with the horizontal. So we have FC cos phi. Now the sign is positive because the horizontal component of FC will be on the positive x-axis, so the sign is going to be positive. So now that we have the horizontal component of FC, the next one is to find the horizontal component of FB. FB is directly on the y-axis. The horizontal component is going to be zero. How that becomes zero is very easy because you are going to have FB cos 90 because FB is making an angle of 90 degrees with the horizontal. Okay, cos 90 is zero. 0 multiplied by FB is going to be zero. So FB disappears. Please make sure you understand that concept. It's very important. If you have any question regarding that, ask me in the comment section. I'm going to try and make sure I respond to you as quickly as I can, as quickly as I read your question. Alright, then the third force we have is FA. What is the horizontal component of FA? The horizontal component of FA will be FA multiplied by the cos of the angle FA makes with the horizontal, because we're looking for the horizontal component. That gives us FA cos 47. What you would notice here is that the sign is negative. Why is the sign negative? Because the horizontal component of FA would be on the negative x-axis. So pay attention to that. That is important. FC cos phi minus FA cos 47. We do know that our FA is 220 and we do know that our FC is 170. Don't forget that the summation of all the f of x summation of f will be equal to 0. So summation of all the horizontal components of the forces would be equal to 0. If we plug in all of those values and our understanding into this equation, we obtain Fc, which is 170 cos phi, equals 220 multiplied by cos 47. 220 is our Fa from the question we have here. What we did here is that we said Fc cos phi minus Fa cos 47 is equal to 0. If that happens, we can take minus Fa cos 47 to the other side, all right, or we can add Fa cos 47 to both sides. If we do that, we obtain Fc cos phi is equal to Fa cos 47, and then that is exactly what we have here. So we have our Fc 170, Fa 220, and then if you make cos phi the subject of the formula, or if you use some of the concepts I have already taught you on the previous videos, you will find your phi to be equal to 28 degrees. All you need to do is find cos 47 from your 4-figure table or your calculators, your scientific calculators. Once you obtain that, multiply it by 220, you're going to get a value. Whatever value you get, divide both sides by 170. So you are left with cos phi is equal to 220 cos 47, the value obtained, divided by 170. Once you obtain a figure for that, your phi will therefore be cos inverse of whatever value you obtain by the time you divide what you have here by 170, and cos inverse of that will give us phi is equal to 28 degrees. I haven't found that, we're not done yet, because we were asked to find Fb and phi. So we have found phi. How do we find Fb? The next thing we want to do right now is to try to find the summation of all the vertical forces acting on the tire. All right, what is the vertical component of Fc? For the horizontal component, we said the horizontal component is going to be Fc cos phi. All right, from the concept I have taught you in the previous courses, if you have not watched the courses I gave you on vectors, please try to watch those videos or try to listen to those teachings, those lectures, so that you can understand exactly what we are doing here. I've already given the concept on how to find the horizontal component and vertical components in some of the videos I already made. So go to this channel and then you can find those videos and watch them, so you can understand why we are using cos for horizontal and why we're using sine for vertical. So for the vertical component, we have Fc sine phi plus Fa sine 47. The reason Fa is now positive, initially on the horizontal it is negative here, now it is positive because when you convert Fa to vertical, what do you have? You're going to be on the positive y-axis, so you have plus Fa sine 47. In this case, our Fb is not 0 because Fb is directly vertical, and since we are trying to analyze and evaluate vertical forces, Fb automatically becomes minus Fb. If you like, you can say minus Fb sine 90. We do know that sine 90 is 1. 1 multiplied by Fb will give us Fb. Why do we have minus here? We have minus here because Fb is on the negative y-axis, and the summation of all these forces would be equal to 0. So if you have this equal to 0, the next thing you want to do is to plug in all the values that we already know. You can first of all make Fb the subject of this entire equation. If you do that, you move Fb to this other side, so you have Fb equals Fc sine phi plus Fa sine 47. All right, if you have that, you have your Fb will be equal to Fc is 170 multiplied by sine 28, because we found our phi to be 28 degrees. So we have 170 sine 28 plus Fa, which is 220 sine 47. If you carry out simple arithmetic calculations here using your calculator or your 4-figure table, you will obtain Fb to be 241 newtons. So we have Fa is 220 from the question, Fc is 170 from the question. We found Fb as 241 newtons from our own analysis. Don't forget, always make use of your unit whenever you are making calculations or analyzing anything in physics. Okay, so and we found our phi to be 28 degrees, and this sums up the solution for this particular question. Before we go to the next example, let's take a short break.
Editor Prof. Editing, writing, plagiarism, acceptable projects, research proposals, papers, projects, and thesis, business writing and grant proposals, books and magazines, cover letters and resumes, social media and blog posts, range of services, proofreading, intermediate and deep expert editing, plagiarism reduction, writing. Why Editor Prof? Fast and affordable, experienced and reliable, satisfaction guaranteed. offers multiple revisions, honors confidentiality terms, certified to edit, proofread, and get your work in awesome shape. Contact details: calls/WhatsApp +90 533 847 7359. Hire Editor Prof. We make your work look perfect.
Welcome back from the short break. Now we have the next example. Given that we have mass capital M equal to 3.3 kilogram and the massless frictionless pulley, and then another mass of 2.1 kilogram hanging. Okay, so we have a diagram here, we have a figure here representing this question. So the first mass, capital M, is here. It has the mass of 3.3 kilogram and is hanging on the massless frictionless pulley. We have a second block, which is the hanging block, and it has small m as its mass here. It is giving us 2.1 kilogram. The hanging block will fall and the sliding block will accelerate. Okay, so when that happens, there will be an acceleration. So our job, the question is to find the acceleration of the sliding block, find the acceleration of the hanging block, and then the tension in the core that is holding the two blocks together. Okay, so this is the sliding block, this is the hanging block. The sliding block is on horizontal axis, as you can see here, so the acceleration will be represented with AX. The hanging block is on the vertical axis, as you can see, is hanging, and then the acceleration is going to be represented with AY, and we do have a frictionless pulley. Okay, so let's go ahead. The first thing you want to do once you have an understanding of the question is to draw your XY plane. Okay, you draw the Cartesian coordinates and then try to understand what is going on there to make life easy for you as you go on. Since we have two blocks here, we're going to draw two different XY planes, or two different Cartesian coordinates, one representing the sliding block and the other representing the hanging block. So for the sliding block, this is what we have. Let's assume this is the mass resting on the frictionless surface for the sliding block. For this block, there is a normal force that will act on it. I have already explained in one of the lectures we had in recent times the number of forces that act on a body or a mass that is resting or in motion. One of those forces is the normal force, which is the upward vertical force. The second of the forces is the weight, which is the downward vertical force. Okay, so from what you can see here, we have the upward vertical force, which is the normal force in the positive y direction. We also have the weight of the block, which is represented as mg. Weight is always equal to mg, so you have mg here representing the weight of the block, which is the vertical force in the downward direction. Okay, normal force is represented with n, and then we have the weight here as mg. Since we have a rope tied to the block and the rope is hanging on the frictionless pulley, hanging on another mass here, there will be a tension in this cord. So that tension is what we refer to as T, and it is going to be horizontal because it is tied horizontally to the mass. Okay, so that is why we have T. And there would also be an acceleration, and that acceleration will be referred to as AX. So that acceleration is what we have here as our A. Like we said, acceleration is always in the direction of the force. So if our tension is in this direction, acceleration will also be in that direction. This represents the Cartesian analysis of the forces acting on the mass of the sliding block resting on a frictionless surface. Okay, let's take it a step further. To complete this analysis, we want to look at all these forces and identify the horizontal forces acting on the body. You do know that summation f of x will be equal to the sum of all the horizontal forces. So what is the horizontal component of the normal force? It will be 0. I have explained these concepts in one of the previous videos, especially the videos where we talked about vector. So please watch those videos if you have not watched them. So n has horizontal component of 0. What about our mg? It will also have horizontal component of 0 because both of them are vertical on the y-axis, directly vertical on the y-axis. The only horizontal force we have at play here is T, which is our tension. Summation f of x will be equal to T. That is the only horizontal force that we have, and we do know that T will be equal to the mass of the block, the sliding block, multiplied by the acceleration of the sliding block. The acceleration of the sliding block is going to be AX, so T will be equal to MAX. You can label this as your equation 1. Having done that, the next thing you want to do is to find all the vertical forces acting on the body. So if you do that, this is what we do obtain. Okay, Now T is directly on the horizontal axis, it's not forming any angle, or it's forming an angle of 180 degrees with the horizontal axis, so T is not going to have any horizontal component. Okay, and don't forget T is tension and tension is a force. That's why we have T is equal to max. Now N is vertical, so summation of F of y would be equal to N. It is positive y because this is positive y axis minus mg. Why do we have minus here? Because this is downward, is on the negative y axis, so positive y axis is normal force minus the weight, which is mg, so we have minus mg. Summation of all the vertical forces is expected to be equal to 0, so we have n minus mg equals 0. Now why are we not equating this to may? Of course we can equate it to may, but because we are dealing with a sliding block, we are dealing with only horizontal motion, vertical acceleration at this particular point would be 0, so 0 multiplied by the mass will be 0. That's why we have 0 here. In this case ax is not 0 because it's a horizontal acceleration we're dealing with, so we do have our ax intact here. So we have two equations here that we have dealt with. Haven't done all of those, the next thing you want to do is to try to identify what is going on with the hanging block. You can represent it on the xy plane just like we did for the sliding block. So we have the hanging block here. For the hanging block, as you can see, there is no horizontal component, there is no horizontal force at all. All we have is vertical force upward and vertical force downward. The vertical force upward would be the tension, okay, and that tension is going to be pointing right up. So we have tension force here, and then we have the weight of the block, which is going to be pulling the hanging block down, and that's going to be mg, small m here, because that's what we do have in the question. So this is the mass of the hanging block, and then this is the weight, and this is the tension. So this is what we have on the xy plane, or the Cartesian representation of the hanging block. The next thing you want to do is to find out the horizontal forces and find out all the vertical forces. And like I mentioned when we started this analysis for vertical analysis for the hanging block, you will find out that there is no horizontal force at all. So summation of f of x here doesn't exist. It's just going to be equal to 0. So we won't even bother to write it here. What we now focus on is summation of f of y. Summation of f of y will be addition of all the vertical forces that we do have. Okay, so we have tension here is positive because it's in positive y axis, minus we have the weight, which is the negative in the negative y axis, so we have minus mg here. And since we are dealing with a hanging block, so that means we're expected to have a vertical acceleration. By the way, if there is motion, there's going to be a vertical acceleration, so that vertical acceleration is going to be ay. Don't forget that this hanging block is going to be falling down. If it's falling down, that simply means that the acceleration is going to be negative. If it's falling down, it's going to be negative. So we have summation of f of y will be equal to t minus mg equal to minus may. That means you can say t minus mg is equal to minus may. If you rearrange those, you will then have mg minus t equals may. That simply means you just bring may to this other side, and then you bring minus mg to this other side, and then you have mg minus t equals to may, just like we have t equal to max here. Okay, and ay is 0 here, ax is 0 here. So you can label this as equation 3. Now up to this point, if you have any questions, ask me. Don't hold anything back. You can just go to the comment section, drop your questions there, and I'm going to get back to you as soon as I read your question. All right, okay, let's take a step forward. Now, according to Newton's laws and some of the explanations I already gave in the previous videos, if you've not seen those videos, try to find them and check them out. Ax will be equal to ay. Ax represents the horizontal acceleration, while ay represents the vertical acceleration. Ax would be equal to ay, and that can be your equation 4. Now that we have all these equations here, we can substitute equation 1 into 3. Equation 1 says t is equal to max. Equation 3 says mg minus t is equal to may. So if you make that substitution, what we have is mg minus t is equal to may. So instead of writing t here, and instead of writing t here, you're going to write max here, because in equation 1 that we are substituting into equation 3, t is max. So we have mg minus max equals max. Now this ay is normally supposed to be ay here, but this ay has changed, isn't it? It has to change to ax because we said ax is equal to ay. So here we change this ax to ay, we change this t to MAX. If you do that, this is exactly what you are going to have here. All right, once you have these, you can make mg the subject of the formula. If you do that, you can rearrange. If you bring minus MAX to this other side, or you add MAX to, if you add MAX to both sides, you're going to have mg equals m plus m all into bracket AX. This is very, very important. Okay, so as we move on, you can make AX the subject of the formula here. If you do that, you have AX equals m divided by m plus m all multiplied by g. You do know that our small m is given in the question as 2.1 and big M is 3.3. Plug that into the equation. You know our acceleration due to gravity is 9.8 or 10 meters per second squared. You can use any of the two, whatever works for you, whatever is convenient for you. If you plug that in and plug all of those values into this equation, what you would obtain is very straightforward. You will find your AX acceleration, horizontal acceleration, as 3.8 meters per second squared. Don't forget, always include the unit. If you do not include the unit, that is like total failure, right, of your analysis. So always include the unit. So we have been able to find the acceleration of the sliding block, and don't forget, we said that the acceleration of the sliding block is equal to acceleration of the hanging block. So that simply means the acceleration of the hanging block would also be equal to 3.8 meters per second squared. All right, so we found A, we found B. Now we want to find the tension in the cord. How do we find the tension in the cord? We do know that our T, tension, from equation 1 is equal to MAX. We know that our capital M is the mass of the sliding block, which is 3.3 kilogram, and we have our AS as 3.8 meters per second squared. If you plug all of those values in there, you have 3.3 multiplied by 3.8, and then your final answer will be approximately 13 newtons. You would obtain 12.8 or 12.5, 12 point something, and then if you approximate that, you have your tension in the cord as 13 newtons. This is a very important question. Pay attention to it. If you have any questions, at all, because sometimes I know some of these things could be tricky, ask me. That's why I am here. That's why I'm making these videos. Don't hold anything back. Go to the comment section, ask these questions, and we'll handle them together. I will respond to you and let you know exactly what to do, okay, and clarify any issue that needs to be clarified. Now, thank you for watching this video. If you have not subscribed, subscribe now so that you can get notifications whenever I make new videos on this channel. Also, there are many of your friends you know will benefit from this teaching. They will benefit from this training. Please share this video with them, send it to them, and ask them to subscribe too. And if you have enjoyed this video, okay, go ahead and give me a thumbs up, and don't hesitate to subscribe to AK Academics.